All right, boys and girls, welcome back to the drive-through, a special "You're at Home and I Am Not" version of the drive-through today. Sponsored as always by the deli. Hungry, thirsty, tired? It doesn't matter. The deli's got you taken care of. Stop by the deli and get yourself a Postu latte. Thanks to Sammy for that one. All right, look, 4-1. We got something that's review and something that is difficult that is also review, okay? The midpoint formula. The midpoint formula says if you are given any segment, okay, on the coordinate plane, so let's say we've got some segment on the xy plane. So this point is x1 comma y1, and this point is x2 comma y2. All right, and you wanted to find the point right in the middle of those two endpoints. That's called the midpoint. You should know that already. Okay. Well, algebraically, this is a reminder that to find the midpoint, you do x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. And some of you are probably thinking, oh my gosh, we got big ones and little ones and big twos and little twos and divided bys, and this is so complicated. It's not at all. Please don't ever memorize this, because your brain has more precious need for its space than that. All you are doing is what happens when we add things and then divide. Well, that's called the average, okay? So all you're doing to find the midpoint is taking the average of the x and the average of the y. Okay, that's all you're doing. You know how to find the average. So that's your midpoint formula. You're going to use it throughout this chapter, and we'll start getting into things called coordinate proofs. Okay, moving on. So here's a tougher example of midpoint. The midpoint of a segment GU is 3 comma negative 3. Okay, 3 comma negative 3. That's the midpoint. If G is negative 10 comma 4, negative 10 comma 4, there's G, there's the midpoint, and then somewhere down here then on that segment is U. Okay? Well, all we got to do is remember that the midpoint, okay, so this is 3 comma negative 3. G is negative 10 comma 4, and we are looking for U, which is x comma y. Okay, well, just remember that the midpoint is simply the average. So the x value for this one is the midpoint 3 is x plus negative 10 divided by 2. 6 is x plus negative 10. 16 is our x value. That looks good. That looks like it might be a 16. And now we have to find our y. Well, negative 3 is 4 plus y divided by 2. Multiply both sides by 2. Negative 6 is 4 plus y. Subtract 4. Negative 10 is our y value. I buy that. 16 comma negative 10 is point U. Okay? And that is our answer. So that might be a tougher version of some midpoint questions. They don't really get any tougher than that. All right. So the second part of this lesson, if you look, are these detour proofs. Okay? Now, this is nothing new, but it's nothing easy either. Okay? It just represents that this quarter we're done with the easy proofs, okay? You guys did great on your quarter tests. You should see those grades coming in. And never again will we probably ever have an easy 2-column proof on a test. So if we're going to do them, they're going to be a little bit lengthy, and they're probably going to require a pretty good depth of thought by you students. So let's just practice one and see if this looks familiar. ZPY up here. Let me fill in my given information as you guys are copying this down. Okay, we got Z, P, Y, And then we got WQX on the bottom. And we want to prove that WQP angle WQP is congruent to angle XQP. All right, now let's write down our givens. So we want to prove this. All right, I'm going to write down the givens within the body of the proof. So we are given what? We're given that PQ bisects YZ. We're given that Q is the midpoint. Of WX. We're given that angle Y is congruent to angle Z. So let's mark that. Oh, I don't like that they did that. Oh, I've got unnecessary lines here. Can I erase these? Okay, sorry, my picture was a little messed up. Okay, that's good. Now I'm okay with them saying that angle Y is congruent to angle Z. All right, angle Y is congruent to angle Z. I can mark that now. Okay, got it fixed. Sorry. Angle Y is congruent to angle Z, and I'm given that WZ is congruent to XY. So, lots of givens. WZ is congruent to XY. I'm trying to prove that these angles are equal. Well, this is why it's called a detour proof. Okay, in order to prove that these angles are congruent, I think I'm going to have to prove that the triangle WQP is congruent to triangle XQP. But I don't have nearly enough information to do that. So it seems to me that I'm going to have to prove that these triangles are congruent first, and that's why it's called a detour. If I could prove that those triangles are congruent, then maybe I can use that information to prove what I'm actually trying to prove. So we will start out with our detour, okay? Notice that it says that PQ bisects YZ, okay? So that means that I can say this. I can say that ZP is congruent to YP. And my reason would be definition of bisect. Okay, well now I have that triangle PZW is congruent to triangle PYX by side angle side. Okay, and I can say that PW is congruent to PX by CPCTC. There's my detour. Okay, well, what else have I not used from our given? Okay, Q is the midpoint of WX. So let's use that to say that WQ is congruent to XQ by definition of midpoint. Okay, so I've labeled everything that I have now, and I start thinking to myself, man, it'd be nice if I could get that angle PWX was congruent to angle PXW. Well, I can, because this white triangle right here, that's got to be isosceles. So now I can say that angle PWX X is congruent to angle PXW, and that's because in a triangle, if two sides are congruent, then two angles are congruent. Okay, so now I've showed that this is congruent to that. So now I have shown that triangle PWQ is congruent to triangle PXQ by side angle side again. This is quite a sassy proof. And now I can say that angle WQP is XQP. Perfect. By CPCTC. Hope you guys are caught up on your sleep. Boom!